And I am probably the newest member on the Angular core team. I joined the core team 3 months ago, worked with the rest of the guys in Mountain View. And I've been working mostly on Angular Dart. And we're going to be sharing this talk with our longtime contributor, Victor. And we'll be talking about Angular Dart and what's happening with Angular Dart under the hood. So let's begin. So first of all, Dart, in case you haven't heard about it, it's a language that's built by Google, but it's also standardized now by the ECMA committee. It is yet another compiled to JavaScript language, trying to hide some of the bad parts of JavaScript and give you this more traditional programming environment. So if you come from a traditional curly brace language, Dart seems very unsurprising to you. So that's, if I have to describe Dart in one language, it's unsurprising. It's optionally typed, curly braced, ready to be used for basically any developer. It is compiled to JavaScript, as I said, but also has a developer tool called Dartium, which is a build of Chrome with the Dart VM built in. So that's Dart. Angular Dart is a rebuild of Angular using Dart. And it's been 1 year in active development. We just released 1.0 in October. Woohoo! It's our first stable version. And as Brad mentioned already in the keynote, it's being used in Google for big applications. And they're using Angular Dart and they're shipping code. So in case you're not terribly interested in Dart, though, this talk might be interesting to you because we used Angular Dart as a proving ground for some new technologies, for new ideas that are coming in Angular 2.0. So even if you're not interested in Dart, don't fall asleep for 30 minutes. Listen to us. There's some good ideas here that you'll keep seeing these terms over and over. All right, so how is this talk going to go? What we're going to do is we're going to show you a tiny little app. We didn't want to do a to-do app, so we made a not to-do app. So let me show you the app. And app might be an overstatement for it. It has only one feature, which is procrastination. You just say, I'll do this later, I'll do this later. And oh, you're done. Awesome. OK, so this app, it's not a to-do app. It has one redeeming feature, which is we can talk about it in 30 minutes, and I can show you all the code for it in 4 slides. So here's the first slide, index.html. This should be familiar to all of you. There's only one thing to notice here. There's a to-do directive. So this is where the actual to-do, where the actual meat of the app is. The rest is basically boilerplate, bootstrap. Here's the second part. So if this is the first time you're seeing Dart code, yes, you will agree with me. Everybody can read this. It has a main method. It is very traditional programming experience. So in the main methods, it looks like we're creating some module and we're running an application. And we'll talk more about this. The next part of the app is the actual to-do component, this custom element that we created, the to-do element. This is the what you in AngularJS you'll call the directive. Here we call it a component, more in line with the emerging web component standards. And this is the code that drives that component. And there's a template. You see the template URL. And this is the template for the component. And as the previous HTML slide, the HTML slides for Angular Dart, they're basically the same as AngularJS. You see ng-repeat, ng-click, ng-show, things you all well know and love. All right, so let's get to it. So the goal of this talk is the application looks simple, but Angular is doing lots of heavy lifting under the hood. So we want to show you what really is happening under the hood, so you understand it a little bit better. So when that crazy stack trace pops up, you know you might have an idea where to look, and you might have a better understanding of what's happening. So the 3 major steps as we're building this application, as we're setting up the application, these are 3 major steps that are happening. First one is we're putting the application together. And we're going to talk through that and understand really what is happening under the hood when we do a application.run. Second part is compiling the HTML. how is Angular reacting to this to-do HTML, this to-do custom tag. And the last one is how is Angular reacting to user interaction. So when somebody clicks on this ng-click, what really is happening? So let's get to it. The first part is putting the application together. So this should be a no surprise to all of you. We are big believers in dependency injection. We use dependency injection to get the application together. Dependency injection, of course, it's independent of Angular. It's its own project that is maintained by the Angular team. And it lives in a separate repository on GitHub. You can take it, use it for your server code if you want, because Dart has a server story. You can use it in any Dart project. There's a dependency injection. The application class that you saw, it just contains one big injector, mostly, and one entry point to the DOM. So the application, when you're setting it up, when you're creating the application and calling run on it, what is happening is basically we create one injector, we prime it, we set it up with the Angular module. So all of Angular goods, the compiler, everything else you want to use from Angular is in this module. It goes into the injector. And there's a custom module that you've added, that we've added for this to-do app, which had only one new concept, which is how to build a to-do component. Right? So we introduced one new type. We added to the injector in our custom module. So the injector has two modules, and the application is ready to be run. And as we're talking about the dependency injection, it's very nice to realize the optional types that Dart provides. They give the natural language to express dependency injection. Because we say, I want to have type foo. This is how I construct type foo. So the typing annotations are very nice for doing things like dependency injection. All right, and we call application run. What is happening? The injector, we use the injector to grab a hold of the compiler. The compiler needs a directive map, which is basically exactly what it sounds like. It's a map of all the directives. How did the directive correspond to a custom controller class? The compiler uses directive map, the root element, which tells it where the application lives. Together, they create a view factory. And now we pass a scope to the view factory, and again, the root element to get a view. And now Vic will take it from here and explain a little bit more what exactly is a view factory and a view, and how the story continues from there.
Yeah, thanks. So, yeah, as Rado has just mentioned, the first thing we are going to do is we are going to compile the HTML to a view factory. The view factory is a critical part because it needs to be able to create view quite fast. And I think last summer we had a performance sprint, and we were able to decrease the view creation time by a factor of 3 or something like this. So to compile the HTML, the compiler will visit all the nodes, and for each node that have directives, it will store the configuration in element binders. Let's look at our index. So Angular will actually only consider the ng app part of the index, but we know it. And in this part, there is only one node, the to-do node, that will trigger a directive. So this directive is our to-do component, and you can see here how we use annotation for declaring a directive. So the directive is triggered because the selector, which is a CSS selector, matches the name of our component. Also, you can see that map declared the mapping, and we want to bind the task, the value of the task attribute, to the pending task property on our component. And the exclamation mark in front of pending task means that the binding will be active only once to initialize the property, and then the binding is removed. And finally, we will load the template from an external file. So that's it for the compilation phase. It was very simple, and now we can instantiate the view. So when we instantiate the view, we are going to use the element binders to configure each of the nodes. And the element binders will instantiate the directive and configure the nodes. So the configuration will be different according to the type of directive, and we will see all of them in the coming slides. For the to-do component, which is a component, we are going to use a component factory to configure it. And in Angular Dart, component uses Shadow DOM. So the first thing the component factory will do is to create a shadow root to host the content for the component. So Shadow DOM really allows to have the component isolated from the rest of the page, and there is no interaction between the component and the page. Next, the component factory will instantiate the component, and it will create a scope for the view. It's a little bit different than JS, because in Dart, the scope and the context are different. The context is only a property on the scope, but anyway, so we'll set the context to the instance of to-do component we have just created, and then we'll set up the binding so that the expression in the task attribute is used to initialize spanning task. And the last thing we do is to load the template. So we'll fetch the file, and as it's HTML, we will compile it to a view factory once again and create the content from this view factory. So let's look at the content for the components. So we'll display the number of pending tasks on top, then we list all the tasks, and below we have a message when we have no more tasks pending. So if we want to compile it, the first node that will trigger the directive is the B node. So it will trigger the directive because the text contains double curly brackets. So it's a text message directive. The goal of the directive is to replace the expression by its value. Then, because the list item has ng repeat attributes, we are going to trigger ng repeat directive. And this one is a bit special because it uses transclusion, as you can see on the children value. So what this means is, first, that the list item is going to be removed from the DOM, and we will create a viewport. So we still need something to anchor the viewport. So we create a DOM command so that we can anchor the viewport. And a viewport is like a slot when we can insert views. We'll see that right after. Yeah. And next thing, because it's a transclude, we need to compile the list item elements. So when we compile it, task triggers a text message, and ng-click triggers a ng-event directive that will be responsible to call the complete task callback when you click on the link. So now we have a view factory to create list item, and we have also a viewport. So you can imagine how ng-repeat will be able to create views and to push them in the viewport to form the list. Okay, the last directive that is getting compiled is the last B node. So ng-show will hide the node by putting a class until the list of tasks is empty. So we are done with the compilation. Now we'll instantiate our template to be the content of the component. Okay, so the first thing, when we instantiate the template, the first directive we'll handle is a text message. So it's simple directive. It will only add a watch on the length of the pending task, and when the length is updated, it will update the text. Maybe more interesting is how we set up ng-repeat. So we create a new injector dedicated to this node, and we instantiate the directive with this injector. And because, as you can see, the prototype of the constructor for the ng-repeat directive, it takes a viewport and a view factory. So the injector will inject the viewport and the view factory, and ng-repeat will be able to create list item and to put them into the viewport to form the list. So last thing we do is to set up the binding. So our expression is used to initialize the expression property on ng-repeat. And expression is actually a setter, so what ng-repeat will do is to parse the expression to extract the list expression, which is pending task, and it will add a watch on this so that when it gets updated, ng-repeat will update the DOM. Last, we will set up the ng-show directive. So once again, we create an injector that is dedicated to this node, and we create the directive with the help of this injector. So the ng-show directive gets a reference to the element, the B node, and it will be able to add and remove class from this element. So at this point, this is what the HTML would look like. You see that the first text message is not replaced yet, and the list has disappeared because the viewport is empty. So now Angular will run a digest, a scope digest, and it will evaluate all of the expressions and call the directive to do some modification. So the first expression we will evaluate is the list of tasks, which is the task attribute on the to-do node. And it will use it to set the pending task property on our component. Okay, and because you remember it was a one-time watch, so this watch will be removed so that it's not re-evaluated again during the next digest. Next, ngRepeat has a watch on pending task. And because pending task is now a list of 3 items, we'll create 3 different views and add them to the viewport. And because each of the view has a task in the text message, it will create 3 new watches, add 3 new watches to the end of the list. So this is how the HTML would look like at this point. Then the text message will evaluate the length of the task. So at this point, it's 3. And the text will be updated. So you can see the updated text on top. Okay. Next, ng-show. We evaluate if the pending tasks are empty for ng-show, and they are not. So ng-show will add the ng-hide class to the element so that the element is hidden. So this is what we have at this point. And now we are going to evaluate the task for text message. And because each task is in a different view and each view has a different context, the task will evaluate to a different value in each of the context. So for the first one, it will evaluate to demo. Then in the context of the second view task, will evaluate to presentation. And in the context of the last view, task will evaluate to Q&A. So at this point, we have our final HTML. And now Rado is going to explain you what is going to happen when you click on a Do It Later link.
All right, so we have our app up and running, but it's an application. It's not a static page. We need to do something when a user clicks. We want to have some interaction. All right, so what do we want to do? What do we really want to do? We want to evaluate an expression, and the expression is clear. It is complete task $index when the click on the anchor tag happens. Evaluating expressions is easy, right? Some of you might say, I know how to do this. DOM 1.0 supports it. You just need the click attribute. The real hard part is the evaluation context, right? So if you just try to do the naive thing, you set the click attribute, the expression will be evaluated in JavaScript, except the context will be the anchor element, and the anchor element does not have a complete task symbol, so you're going to fall back into a prototype chain, into the HTML anchor and HTML element. This prototype chain, this is not what you want. Those are not the context where you want to evaluate the expression. What you want, this is the context where we want to evaluate the expression. The context is, we want a place where we know what $sign event is. That is the browser event. We want also another context where $index is, which is the ngRepeat index, and that exists in the scope for the ngRepeat. And the actual function for complete task, that function lives in the to-do component. So if we are to make an evaluation context, we would like to have this chain of 3 contexts hooked together prototypically. And if a symbol is not in one of them, we fall back to the next one, and so on. And that's what we did. That's what Angular does. Angular takes this expression, creates this chain of contexts for you, and then evaluates the expression in this chain of contexts. And if you're coming from, again, AngularJS, You say, I know this, the evaluation context is a chain of scopes. In Angular Dart, it's subtly different, that we allow ourselves to evaluate in a to-do component, which is technically not a scope. Right? So at least one of these evaluation contexts is not just a scope. And that allows us to have nice and clear short expressions. So instead of writing ctrl.completeTask, you notice we just wrote complete task. So the expression was short. And I'm giving you here two examples. The current, what you saw in the demo does not use the event, but the event is, if you want to use the event, you can create another expression which has the event. Because you need to have a way of grabbing the browser event, the native event. All right, and so that is what's happening under the hood. And if you want more details, you can just go to ngClick. And again, all these directives, like ngClick, ngRepeat, we think of them as a thin layer on top of the Angular primitives, like the compilers. So you can go and open ngClick, read the code, understand it, and write similar things if you want. They're not special. There's no if statement ngClick somewhere deep in the compiler. They really live on top using the same tool set that you can use for your own directives. So here is what happens is the onClick setter receives this handler, and handler is the parsed AST for this attribute expression. And then we allow you, it's a callable function. If you call it with evaluation context, it will be evaluated in the context you just saw on the previous slide. And we take this expression, attach it to the, using the DOM APIs, attach it to onClick, and when the click happens, you call this expression. All right, so we saw how ngClick works. The expression ultimately evaluated to removing one item from your list. And let's say we click, we see one item is removed. So the model, which is the list of pending tasks on the left, has 2 items. The view still has 3 items, right? So far I haven't told you how did the view update. And of course, all of you are experts in AngularJS, and you say, oh, there's a scope apply somewhere. And you're right, there is a scope apply. The question is where? So because if you go and look for a scope apply in ngClick, it's not there. If you look for it in ngRepeat, it's not there. So it might be a little bit mysterious. So where the scope apply happens, where do we synchronize the view and the model? So we needed a mechanism. Scope apply is kind of an internal thing. Like we don't want to, ideally, the developer shouldn't be concerned with calling scope apply. It should just happen, and that's best, right? It should be unobtrusive, but we want it to happen on every VM term. We want it to happen after every callback. We don't want it to happen on, I should say, on every non-trivial VM term, right? We don't want to call it on request animation frame and make your application run spare cycles all the time, dirty checking, right? So you want it to happen after every meaningful thing, and we needed this mechanism, and this mechanism actually does exist, and it's called zones. And one really nice thing about Dart, it's natively part of the Dart native library, the Dart standard libraries. It's part of Dart async, and Brian here has a port for the zones from Dart to JavaScript. So you can check out his library to see how to use it in JavaScript. But in Dart, we just use it right away. So zones is a new concept. It solves this problem that we had. So I'm going to spend a few minutes explaining what zones is, because maybe not all of you know what they are. So to motivate them, let's start with a simple event loop. So everybody understands simple event loop. You have I think of it as a conveyor belt. I think that's a useful analogy. On one side, you put the work items, the callbacks that you want done, and there's an executor on the other side that picks them up and executes them. And here, when I say enqueue, I mean a general mechanism. You can think set timeouts, event callbacks, XHR callbacks, whatever asynchronous mechanism you want. All right, so then the conveyor belt is working. There's executor on the one end. If the executor picks up an item F, and item F has another enqueue called G, G goes at the back of the conveyor belt. So far, so good. So what is zones? Zones is adding callers to your event loop. I'll tell you what that means in a second, but if you just remember that, you might not be too far from the truth. So first of all, how do we create a zone in Dart? We use this fork mechanism. So the mechanism of creating new zones is fork. Once you have a zone, we have our myz, you can call run and pass a callback. And what happens, it just goes on the back of the event loop, but there's one extra thing that happened. That callback received an extra metadata, a little label, you might think of it, that said this callback was ran in zone myz in this example, right? So that's what I tried to annotate there in the slide. Every callback in the zoned event loop retains its initial evaluation context. And what good is that? Well, the executor also knows about zones. So when the executor picks up your callback f, created in my zone z, and it's executing its body, and there's another enqueue call inside, this new function g that's enqueued back into the end of the event loop will retain the same zone that the original callback started in. And that's what you see. The caller, might say, the caller got preserved, right? The f was in my zone z, g is in my zone, right? And imagine g does another enqueue, the zone propagates. So you can have a very long chain of callbacks. They're all asynchronous. They all happen later in some other time, but the zone context carried over. And again, here's the unobtrusive nature of zones is enqueue g did not need to know about the zone. The zone propagated automatically, right? So we didn't need to pass a second argument, g comma myz, or call special myz dot run. And this means, so what does that mean for us? Well, now you can imagine what a framework can do. The first callback is the framework, the bootstrap, the application run, and now everything else is the code you write, right? So f in this example is what we write, and g, h, I, everything else is what you can write. But only we needed to start in the zone myz, and now from there on, all your callbacks run in the same zone. But you didn't need to worry about it. You didn't need to know what the name is. You didn't need to do anything. It would automatically run in the same zone. So this is a very nice property of zones. And here's how we make use of it. So our applications have one zone that we create. This is a particular example of a zone. This specific zone has on-turn done callback. So it allows us to do certain unit of work after every VM turn. And that work is calling scope apply. So we guarantee to run scope apply after every callback that is registered throughout Angular. And you don't need to call scope apply ever. You just call it for it. And the application run, right, so that the first step is creating the zone. The second step is during our bootstrap, we just need to start in the zone. And from there on, all the callbacks are in the zone. I can't say in the zone enough. All right, and that's it. Once you have the scope apply, updating the view to reflect the model, then it goes through the same digest cycle that Vic talked about. Scope apply triggers scope digest. Scope digest finds out there's a watch pending task, which has changed. Since it's changed, we go to a viewport and we remove a view from the viewport. And what does removing a view do? A view is just literally a bundle of the scope that Angular created and the HTML nodes. So for the scope, we destroy it, and for the HTML nodes, we pop them out of the DOM. And voila, our application is the model, the view reflects the model. All right, so that's almost all we had to say. One final reminder. If this kind of flew over your heads and it was a little too fast, or you just heard a few words here and there, keep in mind, you'll be hearing a lot more about some of these things throughout the next few days as there's more talks about Angular 2.0 coming. And keep in mind that Angular Dart's out there, it's 1.0, and it does have some of these concepts already implemented, so you can go and play with Angular Dart. And if you hear about zones or views, viewports, annotations, go and take a look at what we have in Angular Dart. All right, that's all we had. Thank you. If you have any questions, come find us and ask us. Like 5 minutes. Looks like we have 5 minutes left. Is it okay to get questions or? All right, so any questions? Yes? All right, so the question is, how is testing different in Angular Dart than in normal Angular? So, let's see, where's Chirayo and Julie?
We'll talk about end-to-end testing.
Exactly. So, as we said, we've built some big applications in Angular Dart, in Google, and of course, the whole testing story, we do have a testing story. So there is a way to run end-to-end tests in Dart. There's, Guinness is the name of the...
Yeah.
Every part of your testing story in JS, there's a port of it in Dart. And the names might have changed, but the functionalities are the same. And everything you can do in JS, you can do in Dart, right? Because it's compiled to JS language. So. All right, any other questions? Sorry, at the end.
No.
Oh, that's right, sorry, yeah. Uh-huh. All right, so the question is, how does, I said we don't need to care about scope apply. How does that translate to external modifiers? So let's see, depends what you mean by external. How external are they? Like, do you need to check if they're in the zone? Okay. So if this service is instantiated by Angular, then it's fine. Because if it's instantiated by Angular, that means all the callback, you're just writing your callback, right? And it looks like a regular callback. But if this happened if your call stack, somewhere in this call stack, we started in a zone, your callback automatically will be in the same zone. So to get it outside Angular Dart, it has to be completely outside your application, which is actually really hard to do in Dart because Dart believes in this one main method. So your whole application has to be compiled together and run through one main. So actually, it will be much harder in Dart to get it to be truly external. But if you find a way to do it through, then of course you have to code scope apply. Sorry, I didn't hear. So the question is whether you can register them. The simplest thing is literally just make sure your service is instantiated by Angular, and from there you just write callbacks. You just use the native APIs, XHR, and it will be in the zone, and automatically will call scope apply.
I think this can happen when you've got JavaScript interoperating with Dart. When you come outside of the return zone, you can just inject the return zone and then
Yeah. So the answer is, if really it's truly external through JavaScript interrupt, you can still, zone is just one field in your application, get a hold of it, and run your callbacks in that zone. And that's the easiest way, it's even better than calling scope apply, because then scope apply is our internal mechanism. All you need to do is make sure you're in the zone. So the question is, the new component uses Shadow DOM, and is this equivalent to using isolate scope? So yes, our components in Angular Dart do isolate scope. So for that, if you remember, there was a slide about evaluation chain for expressions. It really stops at a component. And that's true right now in Angular Dart, and I don't want to speak for Mishko and the rest of the team, but I think it will be true in 2.0. You'll hear more about 2.0 in the next few days, but yeah. Sorry?
When you're talking about servers, is it fair to say that servers in effect a miniature event loop in its own right? So instead of having an event loop where you're processing discrete messages, what you're actually doing is turning a message into a message chain and then treating that message chain as the increase of event.
I'm not sure I followed. You're talking about whether zone is like a message queue?
In a traditional event queue, we have messages sitting on the event queue we pull out to the proteins.
Mm-hmm.
By the sound of it, what you're saying is that when we're taking a message out of the queue in the sewing body, then that message actually acts as a container in its own right for a sequence of operations.
So yeah, I'm sorry, I'm having a hard time following, and I think we're almost out of time. So I'll come and talk to you right after this, and anybody else can come and join us to hear about this. And we're out of time. So thank you very much again, and enjoy the rest of the conference.